Hello again, welcome to my science channel. Today what we're going to do is we're going to have a look at an oscillator circuit, and in particular an astable oscillator. Now what does an astable oscillator means? It's the oscillation is not stable in any one state for any particular long period of time. It's like a free running oscillator. And where would we use these? Well, we would use these normally in areas where we've got sort of like beeping sounds, where you need to make constant beeping sounds like alarm clocks. You also use them in the clock timing circuits themselves, but you need very accurate ones for that. So anywhere where you need an alternating signal, going beep beep beep, or a timekeeping signal, precise times, then you would use an astable multivibrator or oscillator. So right at the heart of our oscillator circuit, we've got this little silicon chip there, and that's a 555 timer chip, and we're going to look at that in a bit more detail later. But if I now turn the circuit on, so if I connect the supply to it, what you'll see is this LED is free running here, so it'll have an on time and an off time. It's happening very quickly, and it can go very much quicker. So if we now look at the signal on the oscilloscope, which allows us to freeze time a little bit, what we can see is you have an on time at the top and you have an off time at the bottom. And now if I do a little bit of switching, we can see the voltage over the capacitor, and you should be able to see the capacitor charging and discharging of this part of the signal in the middle. And that's very important in the actual switching of the circuit, and we're going to look at the relevance of that in the circuit in just a moment. Okay, so this is the 555 timer. It's a DIL package, which means dual inline, and that means it's got contacts on both sides of it, and they're all in line with each other. And then the pins are numbered 1, 2, 3, 4, 5, 6, 7, 8, and we know pin number 1 position because we've got a little cutout on the top of the chip. So it'll work its way around pin 1, pin 2, pin 3, pin 4, pin 5, 6, 7 and 8. Each of these pins have a different function. So we got pin 1, which is your negative or your ground, so you connect your negative supply. 2 is called the trigger. 3 is where you take your output pulse from. 4 is your reset. 5 is your control voltage. 6 is your threshold. 7 is your discharge, and then number 8 is your positive voltage, positive VS or V supply. So that's how you connect the chip in, and in every circuit, not necessarily all of the connections are used. So when we connect this chip into the circuit, we can see, just for simplicity's sake, we number the pins as we've connected them, but they're not necessarily in the positions of the chip, because otherwise our drawing would just look like a plate of spaghetti. So it's just to simplify the drawings, we arrange it in a simplified way. So we can see then that the chip is connected to R1, R2 and C1, and these are essential for our timing. So we can actually alter our timing by altering the values of these components. And when I say timing, I mean the speed at which the LED flashes. Here's the LED there, and that's protected by this 330 ohm resistor, and that's just there to stop too much current going through the LED and burning it out. And as we can see here, then our battery on 9 volt, that's connected into the positive, number 8 as we've said, and into the negative, number 1. Now this is a simplified drawing of what you've just seen on the oscilloscope. Now here are your pulses, so they're the square wave, and T1 is being the part where it's on, and T2 being the part where it's off. And then you can see your capacitor voltage here. So your capacitor voltage is switching at 1/3 VCC and 2/3 VCC. So it's on at 1/3 VCC and it charges up, and VCC being the supply voltage, and at 2/3 it discharges, and that continues through, and that is responsible for the frequency that our LED is going to flash at. And we can calculate, and I'll show you how to do that in just 1 second, how we're able to work out values for T1 and T2, or how T1 and T2 is calculated. So here's T1. This is your on period, so it's 0.693. A lot of people will round that up to 0.7, and that's multiplied by R1 plus R2 multiplied by C. And then T2, once again 0.693, and people will round that up to 0.7, multiplied by R2 and C. R1 is now not in that part of the circuit, so the circuit is altered. And then T, the whole of the time period, is T1 plus T2. So the time period on the wave is T1 plus T2. So that's the whole length of the wave. So what we're doing now is those two formulas you just seen, we're applying that to the circuit. So we've got T1 being 0.693 or 0.7 if you want, times R1 plus R2 times C. So with that in mind then, we've got T1 multiplied by 1000 plus 10,000 times 10 to the minus 6, because it's a 10 microfarad capacitor. Micro is times 10 to the minus 6. So when we work that through, we got a T1, an on time of 0.076 of a second. And we got T2, 0.693 times R2 times C. And when we work that through, then we have 0.0693 of a second. So the off time is a little bit shorter than the on time. Now if we apply that, and we can work out the time period, as we said, time period is T1 plus T2. So if we add those values together, it gives us 0.1453. And then using the frequency equation that we've looked at before, frequency is 1 over the time period. So if we divide 1 by that number, our frequency says is 6.88 Hertz. So that means that our light is flashing on and off at about 6.8 or so, nearly 7 times a second. And looking at that, if you remember when we switched it on first of all, I'd say that's about right. We've got some tolerance in the components, so there'll be a little bit of error in there, but I think that is flashing around about 6 times a second. So I hope you enjoyed that. So as you can see, if you wanted a circuit that's going to give you a pulsing light at a certain frequency, or a beeping sound, or a timing circuit, the Astable multivibrator will work well for you to do the job. We made it with a 555 timer. You can make it out of individual discrete components, but really that's quite a complex circuit. The 555 timer does the job very, very well. That's the Astable multivibrator, and in the future I hope to cover monostable multivibrators as well, and bistables. So anyway, be safe. Thank you for that. I hope you enjoyed. Please comment and subscribe, and if you want me to cover anything, just let me know in your comments. Thank you very much.